All right, so sometimes in chemical reactions and stoichiometry problems, you're not just given one amount. You'll be given amounts of all of the reactants. And the truth of it is that if you have a chemical reaction, there's usually something in the reaction that is used up completely, and then there's something else that's left over at the end. So there's a limiting reactant or limiting reagent that defines how much product you can actually make. So you can only create so much product because one of the items will run out and you can't make any more of your product. So a limiting reactant is the thing that's going to be that runs out in your reaction. So the amount of everything depends on that limiting reactant. Any reactant that remains is excess. All right, so in limiting reactant problems, you're going to be given amounts of both or all of the reactants. You're going to have to do calculations with both or all of the numbers. The smallest answer is going to be your answer. So the smallest answer or the smallest amount of product that you can make with all of those items is how much product you can actually make. Now the reactant that gives you that small amount, that is your limiting reactant. Everything else will be excess. So how many grams of iron chloride are formed if 223 grams of iron and 179 liters of chlorine react at STP? So you're given two amounts here, so basically you're given two problems. So I know that it's still going to be stoichiometry because I'm going from iron and chlorine to a different product. So it's looking for a new substance, so I have to go through the moles still. So I have 223 grams of iron, and I have 179 liters of Cl2. So if I want to go to grams of iron chloride, well, I can't just pick one and do that. I have to know which one makes the smaller amount. So I'm going to go to grams of the product for both of these, and then pick the smallest amount after I calculate it. So if I want to go from grams of this to grams of this, I have to go through the mole. So I need to get the moles of what I have. Then I can go to moles of what I want. Then I can go to my grams. So let's do that. So I have 223 grams of iron. I can go to moles of iron. So 1 mole is equal to 55.845. Now I'm going to go to moles of my product. So moles on top of moles, I'm going to use my coefficients. So it's 2 moles of iron for every 2 moles of iron chloride. So now I'm going to go to my grams. So 1 mole is equal to 162.345. All right, so then when I do the math here, I'm going to get 648.3 grams. So now I've got to do the same thing down here. I can't just assume that one of these will be the limiting reactant. I need to go and figure out, okay, how many moles of the product I'm going to be forming, and then compare those two amounts. So I have 179 liters of chlorine, so I'm going to go to moles of what I have. Then I can go to moles of what I want, and then I can go to my grams. So I'm starting with 179 liters, and this is at STP. This is a gas, so I'm going to use the 22.4 liters. So 1 mole is equal to 22.4 liters. So moles of chlorine on the bottom, moles of iron chloride on the top. Moles on top of moles, I'm going to look at the coefficients. So I have 2 moles of this for every 3 moles of chlorine. So now I'm going to go to grams. And the molar mass is still the same. All right, so then when I calculate this out, I'm going to get 864.87. Okay, so now I've got 2 answers. I pick the smallest answer. So the smallest answer will be the amount of iron chloride that I can make. because once I make this much, I should be out of my iron. So my iron is my limiting reactant, my chlorine is my excess, so I should have leftover chlorine in whatever the vessel is that the reaction's happening in. Okay, so now let's look at another problem. So determine the limiting reactant and the amount or the number of moles of Ali3 produced in the reaction when 1.2 grams of aluminum and 2.4 grams of iodine gas react. How many grams of aluminum are left over? Okay, we cannot deal with this until we deal with the rest of it. So it's really, there's multiple things that we actually have to do here. Okay, so I know it's limiting reactant. It says that it is, but also because it has two amounts of my reactants. So I have 1.2 grams of aluminum, and I have 2.4 grams of iodine gas, so I2. I want to go to my product, so my grams of Ali3. Well, if I want to go from grams of this to grams of that, I have to go through the mole. So I'm going to go to moles of what I have first. Oh, not grams. Okay, we're going to go to moles. Moles of Ali3. All right, so I'm going to go to moles of what I have. So 1 mole is equal to about 27 grams. And then I can go to my moles of my product. Because once I'm in moles, I can go to moles of anything in the chemical reaction. So moles on top of moles, look at your coefficients. So it's a 2 to 2 or 1 to 1 ratio. So then once you divide, you're going to get 0.044 moles. All right, so now we're going to do the same thing for the iodine. We're going to go from grams of iodine to moles of my product. So if I want to go to something else, I have to be in moles. So I'm going to go to moles of iodine. 1 mole weighs 254 grams because remember it's I2. So now when we have moles on top of moles, we're going to look at the coefficients. So there's 3 iodines for every 2 of my product. So that means it's going to be 0.00629. All right, so now we have 2 numbers. Which one is smaller? Well, this one is. So that's the number of moles of my product, and that means that this one is my limiting reactant. This has to be in excess, so I'm going to have leftover aluminum at the end, which unfortunately if you read the question ahead of time you would have realized that, oh, this has to be the excess reagent, the other one has to be limiting. Now I want to know how many grams of aluminum are left over. Well, I know how much I started off with. I had 1.2 grams. So if I want to know what's left, I need to know how much aluminum was actually used. Well, I know how much product should have been formed. So if I know how much aluminum was used to make this amount, then I can figure out how much aluminum was used. So when you're doing this type of problem and you're trying to find the amount of excess reagent left over, you're going to start with your answer. So this is the amount of product that I should have created. Well, how much aluminum did it take to make 0.00629 moles of aluminum iodide? So let's figure that out. So let's go to moles of aluminum. So moles on top of moles, it's 2 to 2, or 1 to 1. Now let's go to grams of aluminum, because we started with grams here, so I need to compare that. So 1 mole is equal to 27. So now when I do this math, I'm going to see that it takes 0.16983 grams of aluminum to create this much product. Well, so this is how much aluminum was used. Okay, this is how much aluminum we started with. So 1.2 grams minus the amount that we used up should tell us how much is left over. So that should be 1.13 grams. So I have 1.13 grams of aluminum left over. And then this is how you would do that type of problem. So you will be asked to solve for the amount of excess reactant left over. So in order to do that, you have to find your answer. So how much product can you create? So with that amount, how much of your excess reagent are you going to use to make this amount? Once you get that, you just subtract it from how much you started with.